Hello, this is a problem from physics textbook, Openstax physics textbook, volume number 1, chapter 4, problem 35. As shown in the figure, a dart is thrown horizontally at a speed of 10 meter per second at the bullseye of a dartboard. So bullseye means the center here of the dartboard, okay, which is 2.4 meter away from the person. As in the figure, how far below the intended target does the dart hit? That means, as you know, when you throw this dart, this will move in a projectile path. So this is a projectile motion because it has a combined motion of x and y. Okay, so we need to analyze this motion. So the second thing is, what does your answer tell you about how proficient dart players throw their darts? Now first we need a coordinate system, x and y. 0 is the origin, okay, and this is the y-axis, then this is the x-axis. Now when you throw the dart starts from origin 0, right? So x-axis 0, y-axis some position, but x is 0. So from there the dart starts to move. After some time, dart hits this blackboard. This is the dartboard. So after some time, the position of the dart is xt. So xt is the position of the dartboard as well. So you write xt is 2.4 meter, which is the 2.4 meter away is the dartboard fixed from the person. Now y0 is the position of the dart when time is equal to 0, the starting position of the dart. In the y coordinate, it's y0 somewhere here, and x coordinate is 0. x0 is 0, y0 has some value. Now this distance, okay, this is 2.4 meter, we know, that is xt minus x0 is 2.4 meter. This red dotted line shows the path of the dart. So dart will not hit at the bullseye at the center of the dartboard. It will follow this curved path and will hit at this bottom some point here. So initial velocity is in the x direction. It's set like horizontally, right? Thrown horizontally. So there is no y velocity, only x velocity. V0x is 10 meter per second. V0y is 0 because there is no y velocity initially. Now xt minus x0, I already told you the difference between the final position and initial position in the x direction is 2.4 meter. So this distance here, okay, in the y direction, yt minus y0. So this position is yt. What is yt minus y0? That is our question. How far below this target dart is going to hit? Okay, so this is y0 position, yt position. Yt minus y0 is the quantity we need to calculate. So we have to check the equations. Which equation is useful here? You can see the equations in y, right? So here the second equation here connects yt, y0, v0, yt, half ayt square. So t is the time taken from the left starting point to the ending point. Okay, so we need to calculate that. So let's take this y equation. First we take y0 to left side, then yt minus y0 is equal to v0 yt plus half ayt square, and v0y is 0, yeah, and what is the y acceleration? It is minus 9.8 meter per second square. Substituting those values here, you get yt minus y0 is minus half 9.8 t square. Now you see, this is the quantity we need to calculate, the how far below the target it's going to hit. So but we don't know t, so we have to analyze the x motion. So you can see that in this equation, okay, which is xt connected with the other quantities like x0, v0x, half ax t square. So in this motion, you know that acceleration in the x direction is 0, right? So let's take x0 to the left side. So that is xt minus x0. We already know that value. Substitute v0x, we know 10 meter per second. And ax, we know ax is 0. There is no acceleration in the x direction. So substituting this, we get this equation. From here, we know the value of xt minus x0. Substituting that, we get time t is equal to 0.24 second. Substitute in the first equation. And calculating the yt minus y0, we get minus 0.28 meter. So this dart will hit 28 centimeter below the center. So a proficient dart player, what he will do, he will adjust the angle so that it will hit at the exact target.